Greetings everyone and welcome to the chemistry program. I am delighted to be here today to discuss this topic. Today I will be discussing the wonderful and marvelous world of chemistry. Today I'm going to talk about the corrosion of metals. The corrosion of metals. Metal corrosion causes heavy economic loss. It leads to deterioration of metallic structure, especially that are made of iron. The mass of iron that may be lost due to corrosion can be estimated by 1/4 of the production of the whole world. What is the meaning of rusting? What is the meaning of corrosion? Rusting means it is the process of chemical corrosion of metals by the surrounding medium. It is the process of chemical corrosion of metals by the surrounding medium. What is the mechanism of corrosion? What is the mechanism of corrosion? This shape illustrates what happens in a piece of iron after a while. In the presence of water, the presence of oxygen, iron in a piece of iron will rust, will form rust, 2Fe plus 3H2O plus 3 over 2O2 to give 2FeOH by 3. In most cases, the corrosion of the pure metals is difficult. Why? Even iron doesn't rust easily in its very pure state. Most industrial metals are always containing different impurities that activate the corrosion process. The contact between less active metal and the more active metal causes corrosion for the more active in the same medium. Less active, more active, two different metals in the same medium, more active, corroded. Therefore, we can conclude that the corrosion of metals is formed due to the formation of galvanic cells or local galvanic cells in which the anode is the corroded elements while the cathode, which is less active one or carbon that exists as impurities, and this which causes corrosion. The mechanism of iron and steel corrosion can be explained as follows. Watch this video well to know what happened in different types of medium. Different mediums: air only, water only, drying agent, salt, water, and air. 5 different mediums. And we will put things made of iron, such as iron nails, in the different solution, and we will watch what will happen, in which this medium the corrosion will be activated. Air only, drying agent, the other in water and air. And in the fourth medium, which is salt, water and air. And in the fifth, water only. And watch well in which this medium the corrosion will be activated. The corrosion will happen rapidly. Appears in salt, water and air. Salt, water and air. The corrosion appears firstly in salt, water and air. Then appears in the other mediums by different rates. This video illustrates the effect of medium on a corrosion process, rusting process. Air only, nothing. Drying agent, nothing. Salt, water and air, the iron nail becomes corroded. The corrosion effect on it, air only, appears some types of rust, drying agent nothing. Salt, water and the air becomes corroded. Air only, nothing to the iron air. Drying agent, nothing to the iron nail. Salt, water and the air, the corrosion affect these things. When a piece of steel is exposed to cracking or breaking, it will form a galvanic cell with water which contains dissolved ions that act as electrolytic solutions, and the ions acts as anode. The oxidation reaction takes place as following equation. 2Fe gives 2Fe positive 2 plus 2 electrons. The ion Fe positive 2 becomes a part of the electrolytic solutions, and the electron transfers through the piece of iron to the cathode, which is carbon impurities in iron. So iron acts as anode and external circuits to transfer the electron from anode to cathode. External circuit. At cathode, the oxygen of air is reduced into hydroxide group OH negative. As you see, 2H2O plus O2 plus 4 electrons, 2 gives 4 OH negative. Iron ions are combined with hydroxide ions to produce iron 2 hydroxide. As you see, 2 Fe positive 2 plus 4 OH negative to form 2 FeOH by 2. Iron 2 hydroxide will be oxidized by oxygen dissolved in water into iron 3 hydroxide, iron 2 to iron 3. Why? We know that iron 3 is more stable than iron 2. So iron 2, it changes into iron 3. As you see, 2 FeOH by 2 plus half O2 plus H2O to give 2 FeOH by 3. This represents the reaction of Fe positive 2, oxidation of Fe positive 2 to Fe positive 3. By addition of the previous equations, we can sum all equation, we obtain the total equation for cell of iron corrosion. 2Fe plus 3 over 2O2 plus 3H2O to give 2FeOH by 3. This reaction represents the mechanism of corrosion. 2Fe plus 3 over 2O2 plus 3H2O to give 2FeOH by 3. A very important note. The rust is a slow process. Why? As the presence of limited amount of ions in water. Again, the rust process is very slow. It's a slow process. Why? As the presence of limited amount, very small amounts of ions in water. And by increasing this amount of salts, this amount of electrolyte, if a big amount of ions exist in water, as in seawater, the speed of rusting increases. What about the factors that causes corrosion? What are the factors that causes corrosion? Number one, factors specific to the metal itself. Factors specific to the metal itself. Factors specific to the surrounding medium. Number one, what about the factors specific to the metal itself? Heterogeneity of alloys. Heterogeneity of alloys. How? The metals that is used in industry mostly exists as alloys, which are difficult to prepare in homogeneous structure. So, a large number of local galvanic cells are formed, which cause corrosion of the more active metals. Number B, the connection of metals with each other. At point of welding metals together or using screws made from another metals, this causes the formation of local galvanic cells, causes corrosion of the most active metals, as in the contact between aluminum and copper. Aluminum is more active than copper, so aluminum is corroded firstly. And the contact between iron and copper. Iron is more active than copper, so iron is corroded firstly. Number two, the external factors or the factors specific to the surrounding medium. The external factors, which are factors specific to the surrounding medium, which are water, oxygen, and salts, are considered from the external factors that causes the process of metal corrosion is higher in any other cases. The protection and preventing metals from corrosion, especially iron, is considered from the basis of the protection of the international economy. Iron is protected by different ways, such as covering it by another substance to isolate it from the surrounding medium. This is happened by one of two methods, which are: number one, coating or painting iron by the organic materials. For examples, painting by oils, varnish, or primer, but it is not effective method on the long period or on the long run. Number 2, covering iron by corrosion resistant metals. Covering iron by corrosion resistant metals, like in steel galvanization process. By dipping steel in molten zinc. As you see, the iron tools dipped in caustic cleaning firstly, then rinsing to clean it, then beckling, then rinsing again to clean its surface from any substance. And flux solution, dipped in a flux solution. Finally, the galvanizing process, dipped in a molten zinc bath. Then cool it. And quality assurance. Magnesium is used to protect steel used in ships industry. Tin is used to protect iron that is used in cans. There are two ways to cover metals. What about them? There are two ways to cover metals. What about them? A. Cathodic protection or cathodic cover. The effect of corrosion on iron wires and iron things. As you see, rusting will affect on the iron things, and anything this lead to cracking. So this car, what happened to it? Oh, due to the corrosion. This happens due to the corrosion. The cathodic protection takes place by covering with less active element, by covering the metal with less active element. If the protective element is less active, like tin, than the original element, such as iron and tin, iron more active, tin less active, what happens? A galvanic cell is formed in which iron becomes more active metals and anode, while tin becomes less active metals and cathode, so iron corroded. Therefore, iron that plated with tin corroded on scratching faster than iron. Iron that plated with tin corroded on scratching faster than iron due to the formation of a local galvanic cell. Iron becomes more active and anode, while tin less active and cathode. The another way is anodic protection or anodic cover protection. The way to protect iron from corrosion protection. If metal A more active, it corroded. If metal B more active, it corroded firstly. Okay? And magnesium or zinc, magnesium or zinc comes before iron in the chemical activity series. So, if you connect between them, zinc becomes the anode and the iron becomes the cathode, as you see. And the zinc corroded firstly, while iron, nothing takes place to it. Okay? And this is called anodic protection. By covering the metal by another more active metals like plating iron by zinc, that is called iron galvanization, where zinc precedes the iron in the electromotive series. Then galvanic cell is formed in which Zn acts as anode, so it is corroded completely first before starting of iron corrosion, which takes a long time as iron corrosion begins at its surface. Very important notes. Number one, ship chassis are continually in contact with salty water, and the iron pipes, which are buried in moist soil, so they are exposed more to corrosion. The concentration of ions affects on the speed or the rate of the corrosion process. Number two, to protect them by connecting to the more active metals than them, like magnesium. Magnesium, in this case, acts as anode and is corroded instead of iron. So it is called, magnesium in this case is called as the sacrificing electrode. Corroded instead of another metal. In this figure, magnesium, iron pipe buried in the soil, connected to each other, magnesium is corroded instead of iron pipes. And this process or this electrode called sacrificing electrode. As we came to the end of our program, I hope everyone found it interesting and had a good time watching us. Thank you, and till we meet again, I wish you the best of luck.